Okay. First things first. I'll get some notes out. Quizzes are in. I put them in the book. Awesome. So there's a few of you that do need to do it. So if you missed this past Tuesday last week, you do need to make it up, please. Which could be goofy. So I will put this quiz, if you owe me, I will put it in the Math Science Testing Center, which is down the hall. It's not open every day. The reason I'm going to put it in there is two reasons. One, I might find out like at 5 o'clock tonight, but I might have jury duty. Yeah? So my civic duty might need to take place, and I find out tonight. So if I'm not here tomorrow, and there's some random sub, this is what I'll do for you. I will move one of the Chrome cards in here. I will each night that if I am on a jury, I will record my lecture, and then there will be a packet of notes for you to take if it's that day. If it's not a note day, if it's just a work day, then I'll have all of the problems worked out, and it'll be on the video as well. So it'll be like I'm here, but I'm not. So that's what I might have planned. Jury duty is jury duty. I know some people say, "Oh, I just always skip it. I ignore it." It's you want to have a. I think I am somebody that you would maybe want to have on a jury because I am relatively analytical. But then I also might not be the guy you want on a jury because I see through EB. Yeah. I guess I'd have to bring my computer to the hotel room and have to teach from the hotel room somehow. But, who knows? But there always is that inside chance that I call and they say, "Hey, juror number, blah blah blah, you don't have to come." So that'll be that. I just wanted to forewarn you if it does happen for the next couple days. I do have a plan in place to ensure that you can take care of that. Again, if you missed the quiz, I'll put it down in the Math Science Tutoring Center and Testing Center. And again, it's not open all the time, so please go and figure out the hours. That's your responsibility to figure that out. It's not mine. Let's see. Testing. It looks like testing is available Tuesday and Thursday this week, all periods. So if you are one of those kids that needs to make up this quiz, it'll be in the testing center, and it looks like, unless Mr. Anderson goofed up, but I think he's probably got it right, Tuesday and Thursday this week, periods 1 through 8. If you're one of those as your off period, please by all means go in there and take the quiz. The quiz isn't there yet. It'll be there by 4th period today. But that doesn't help because it's not open today. Okay? So, yes.
How many weeks are you going to give us to have the study package for?
I hope to get that to you the Monday, so you'll have almost a full week.
To just do it without.
Yeah. So hang on, let me look at the calendar. So we have this whole week. We're finishing up the inequalities, and then we have a word problem unit that we start on. So we'll go through that. Monday next week will be when we start the take-home test, and then we have an in-class test on Tuesday next week, so a week from tomorrow. And then we have 5 days of a statistics unit. And then, so I hope by December 6th, 7th, or 8th, somewhere in there, or maybe the 11th, we'll have the take-home packet. But there is a few things on statistics to do. And then we have, So basically, between now and the end of this semester, we have an in-class test a week from tomorrow. We have a stats quiz 2 weeks from Wednesday. And then December 14th and 15th, we have just solely dedicated to doing, working on finals, like reviewing. December 18th, that's a Monday, we have an in-class part of the final, and then between 12:19, 12:20, and 12:21, we'll have a longer class period where you guys have like a partial day, and we'll go with that. So that's what's planned. Does that help? Sweet. Good question. All right. We are going to continue our adventure with inequalities. And linear equations and systems of linear equations. But when you deal with an inequality, you're, rather than looking for your solution being a point or an infinite or a no solution, you're looking for a region to shade. We've worked with linear inequalities in the past where we just had one where it's like you have your line drawn, it's either solid or dotted, dictated whether you have greater than, less than is dotted, greater than with an equal, less than with an equal, solid, and then you shaded either the top or the bottom. But now when you have two lines that cross each other, you create four regions, and there's only one of the regions that's truly a place to define it. So I made these a little bit bigger so you had a larger grid to look at rather than having 6 of them on a page. But let's see if we can start walking through these where we can go. Okay, so warm up. The very first question, we have y is less than 1/2 x plus 4. So a few things to remember is this will be a dotted line. Does everyone feel comfortable with that? So let's go ahead and graph this. This will have a y-intercept of 0,4. And then I have a slope of up 1, right 2. And we already said it was a dotted line. And then we chose something called the test point, right? And so a lot of times the test point, a real good, easy test point would be 0, 0 if the line doesn't go right through the origin. Remember that? So this could be our test point here being 0, 0. So what we'll do with that 0, 0, we'll plug it in. So we have an x and we have a y value. So if I plug it in, I get 0 is less than 1/2 times 0 plus 4. So I get 0 is less than 4. Is that true or false?
True.
It's true, right? True. This is a true statement. So that means you shade the region below. So you shade this whole region down here. Right? Remember that? And of course, this is where I made the joke of you get the one kid who's shades nonstop. He's got the little nub of a pencil. Shades the whole thing during the test. He's got the squeaky desk, so it's making that. Sorry, being silly. You guys know what I'm talking about? So, and then, hey, mister, do you have an eraser? No. Because then he turns it over and he's got the eraser that the metal is sticking out the top because he uses so much. And create holes in that scraping noise on the desk. Sorry, not good for Monday. All right, so how do you feel about that one? So the entire yellow region below the graph is the solution to this problem. Does that make sense? Okay, let's take a look at problem number 2. First question, is it solid or dotted? It's got the equal sign, so solid, right? Does that make sense? You see the difference between this sign and this sign? This one doesn't have the equal, so it's dotted. This one does, so it's solid. That problem is set up that we could use the cover method, which the cover method will allow us to see where it crosses the x-axis and the y-axis as points. So if I cover up this right here, I get 2 times x equals 6. So 2 times what number gives me 6? 3. So I get in the x direction 1, 2, and 3. And then if I cover up the x component, I get negative 3 times y equals 6. So negative 3 times what number gives me positive 6? -2, so that's down here. And it said it's solid, right? All right. So would 0, 0 be an okay test point? Yeah, the line does not go right through 0, 0, but this right here would be our test point, 0, 0. Now let's plug it in. So I get 2 times 0 minus 3 times 0 is less than or equal to 6. So 2 times 0, that's 0 over here, is 0 less than or equal to 6? What do you think? Is 0 less than 6? Yeah, so that's true, right? So where do we shade? Above the line or below the line? Above. We shade the region that our test point would be at. So our test point happens to be above, so we shade this region right here. All right? So that whole yellow shaded region is our feasible region that the answer falls into. Is there any questions so far about each of these? So the first problem, we were able to plot the y-intercept, use the slope to find a second point, because that was in slope-intercept form. The second problem, we were able to use the cover method to find where across the x and the y axis. And then the last part of it, once you graph it, you figure out if it's solid or dotted. Solid if it has the equal. If it doesn't have the equal as part of the inequality sign, then it's a dotted line. And then wherever your test point takes place, if that creates the true, if wherever your test point is, whether it's above or below your line, if it creates a true, you shade that region. If it created a false, you shade the opposite side of the line. Does all of that vocabulary seem to make okay sense? May I adjust and move to the next slide? We good to go? Okay, next slide. So now we have two inequalities. So we have two lines that we're going to graph on here. So we learned this in the last unit, that two lines, they can cross each other, they can lie right on top of each other, or they can be parallel. So if they cross each other, where you had one solution where they cross, there's one of four regions your graph could be shaded. If you have two lines that are parallel to each other, it's very possible to have one region in between them to shade for the solution, the two outside regions, or a singleton outside region, okay? Which is different than when we were doing parallel lines before. Parallel lines we said had no solution, right? But we could have a region that's the solution with parallel lines. And then if you had same line on top of itself, it becomes like one line where you either shade on top or below. So let's walk through this pretty slowly. You stop me if I do something that is goofy. This top equation is dotted. This bottom equation is solid. Pausing there. Does everyone agree that it works that way? If not, do you comprehend what I did right or wrong? So if we have that little equal sign underneath the inequality sign, that means it's got to be solid. If it's not, it's going to be dotted. Okay? So this first equation, I have a y-intercept of what? 0, 5. Good. And then I have a slope of what? 1/3. So from that point, I'm going to go up 1, right 3, correct? Up 1, right 3. And then we got a solid line, or a dotted line, right? Is that okay? So let's pause there for a sec. Would 0, 0 be an okay test point on this line? Yeah. So 0, 0 is right here, right? So I'm just gonna let me make a. Let's see, that bright green. So my test point is gonna be right there for right now. Is that okay? So let's just see if that works. So let's plug 0, 0 into this and see if it gives us true or false. If it gives us true, we'll shade down here. If it gives us false, we're going to shade on top. Is that okay? So let's plug 0, 0 in. So I have 0 is less than 1/3 times 0 plus 5. So is 0 less than 5? That's true? Yeah. Okay, so let's do this. Highlighter, let's make it yellow. So that means that I'm going to shade this region down here. I'm going to shade the whole thing in because I want to show you what will happen. It's going to happen here in a second. Okay, so far we have solved the first equation. Okay? Make sure I know this is dotted. Let's go ahead and draw the second line. So we did that one blue. Let's do this one in red. Okay, that's going to be a solid line. So what's my y-intercept of the one that I just circled in red?
-4,
0. So 0, -4. 2, 3. So it's down here, right? Right? And then my slope is -2, which is the same thing as -2/1. So from that red dot, I'm going to go down 2 and right 1. I'm going to go down 2, right 1. Was this one going to be solid or dotted?
Solid.
Solid, okay. So we're kind of ignoring right now that we have already shaded a region. We have this other thing. Though we do indeed see these intersect each other, which if these were equal, you would try and figure out what that point is. But right now, we're going to figure out which region to shade. Does 0, 0 seem to still be a good test point on this line? You think that would be all right? So if I tried 0, 0 on this one, so I'm going to get 0 is greater than or equal to -2 times 0 minus 4. 0 is greater than or equal to -4. 0 larger than -4 or not? It is. So that means I'm going to do this. Now watch carefully what's going to happen. If this works like the other smartboard, it should do something unique. Let's see. So that means I'm going to shade this whole region over here. Oh, it's not going to work like the other one. So I'm going to show you how I need to correct that. So this is the whole region that works here. But this is the shared region right here. So 0, 0 was right here. So this region underneath the blue and to the right of the red is the only region that the answer is. Notice I still have a green shaded region and I have a yellow shaded region. The yellow is the true region for the blue line, that dotted line. The green is the true region for the red line, but the solid, the dark patch, that's where the two regions are shared. Okay? So in this case, what you're really looking for is if you use a test point, you're looking for the region that tells you that you have a true and a true answer. Okay, let me repeat that one more time. When we pick our test point, when we plug our test point into both of our equations, our test point will indeed tell us if we have a true and a true. So this region right here would have given me true and true if I had plugged in 0, 0. Meaning it would have been true on the one equation, it would have been true on the other equation. Being we have true on both, that's the region that we're concerned with shading. I don't care that you shade that I can see the green and the yellow. I'm more concerned that you shade the correct region. So two thoughts on this. You know, graph one, shade the region. Graph the other, shade the region. Wherever the shared region is the, or the overlap region is where the solution exists. How many points exist down there where it says true, true? 3, 20, 400, 200 trillion, infinite? Infinite, yeah. So that means that if I pick any points, any ordered pairs of points, whether it's 0, 0 or anything out here, continuing out forever, no matter where I pick, as long as it's within that shaded black region, or dark gray region, wherever that color is trying to be, it would give us a true and a true. So 0, 0 is just a really nice test point, but it doesn't have to be the only test point we use. Is everything okay so far?
Yeah.
All right. So, let's see what we got. The next thing is steps for solving a system of inequalities. Graph the first line and shade the points that work. Okay, we did that. Graph the second line, shade the points that work. We did that. And then highlight where the shades overlap. We did that. Those are our 3 steps to solving a linear equation. Okay? Everything all right? Good. Huh.
Boy, I hope BCS got all mixed up with college football, man. Oh, dude, Auburn. Oh yeah, Alabama was just.
Auburn beat out. That was unbelievable. And Miami lost.
And then yeah.
So what I'm really gonna laugh at though, Georgia won, right?
Georgia won.
Yeah.
They have the same record as Alabama.
So what's really gonna crack me up though when this week's ratings come out, if Wisconsin's still the 5th rated team.
No, Alabama's 5th now.
Oh yeah,
Alabama's not.
Auburn's won.
Auburn.
I take that back. Clemson's
Clemson won,
Auburn's 3.
and then Oklahoma,
and
and it's somewhere in there, and then Auburn. So one of my students from many years ago, he's a big old lineman, was playing for Auburn, and he was at that game that I don't know if y'all remember. They
returned a punt. I mean, a field goal.
Returned a field goal.
That's what I thought they were going to do.
Oh man, that was so pretty. He goes, hey, Mr. Sir, I've never heard a crowd so loud in my life. I mean, in that stadium, on the sidelines going, this is ridiculous. People are jumping over the rails like, yeah.
That was when Auburn lost. I mean, won because they returned it.
Yeah. That was beautiful. I love college football. This stuff.
They tried to break the coach.
All right. We have 2 more examples here. Let's see. The top equation, I would say this is dotted, and the bottom one is solid. Everyone feel okay? Hey, do you think I could have 2 solids or 2 dotteds?
Yeah.
I sure could. It's just that this is one of each. So the top line we'll do in blue. What's my y-intercept at the top one? 0, -1, good. And my slope, I'm going to go from that point, I'm going to go up 1 right 2. Does that make sense?
Yeah.
And this one was dotted. Okay. Oops, let's make that a little bit better dotted. Okay. All right. So let's keep in mind 0, 0 might work as a good test point because it's definitely above it, but let's not use it yet. Let's hold off on using it for a moment. So let's go ahead and graph this bottom one here. Okay, so what's my y-intercept of that bottom? 0, -5. Okay. And then what's my slope? -2/3. So I'm going to, from that point, I'm going to go down 2 and right 3. 1, 2, 1, 2, 3. Solid or dotted? Solid, okay. Does it appear that 0, 0 might be an okay test point?
Yeah.
Okay, now what did I say this about our test point? What has to happen with our test point? If I plug it into both of the equations, what has to be the result for that to be the shaded region?
That's true.
Both of them have to be true, right? So if I get a true-false, I have to pick a different region. Okay, so let's just do this. So I know last time I said, hey, let's try it here, shade that region, try it here, shade that region. But let's just hold off on that for a moment. Let's see if we can figure this out. So I have 0, 0. Okay, that's above the blue. It's above to the left of the blue and above to the right of the red. Does that make sense if I use that vocabulary? All right, so let's take 0, 0, plug it in. So if I plug it in this top one, I get 0 is greater than 1/2 times 0 is 0 minus 1 is 0 greater than -1. Yeah, so that gives me true. Okay, so far right now I can tell you I shade on the top section of the blue. Okay, if this gives me a false on the red, that means I have to still shade above the blue, but on the other side. Well, let's take a look. So let's plug 0, 0 in here. So I get 0 is less than or equal to, what is -2/3 times 0? 0. So 0 is less than or equal to negative 5. Is 0 less than negative 5? Is that true or false? False, right? You rather owe somebody nothing rather than owe somebody $5, right?
Yeah.
So that gave me a false. Okay, so let's use a little logical thinking here. A little logical thinking. So the blue gave me true. So that means I would shade all of up here for the blue. Agreed? The red gave me a false. So, oops, where did that line come from? Show up. What is this? What's going on there? Get back there. There it goes. All right, so I shade up here for the blue. Okay, that's all over here. Okay, the red gave me a false. So everything over here on the red, everything over here won't work. So everything underneath the red will work. So what region, try and use some good vocabulary, what region would you think we shade? Where did the true and true exist? We just found that this was true and false. And I will tell you that down here, this would be a false and a true. Right down here? Okay, hang. So let's see if we can make that make sense. So I can guarantee with the blue line, I shade above the blue line. Okay? So if I shade above the blue line, I definitely can't shade down here. Right? So this is going to give me a false over here. So if I pick over here, if I picked a point over here, so if I pick, I don't know, negative 10, 0, it would give me a true and a true. Okay, but I'm just using logical thinking, saying this gave me true, false. I knew above the blue was true, but I know below the red is false. So this is above the blue and below the red. So the region what we're going to shade is, well, let's use a crayon. Yeah, baby. So right here is our shaded region. This is where our answer exists. Somewhere in here. Is that okay? Will you all try this number 2? Try it on your own. See how you do. Try that one on your own. See how you do, okay? How do we do? Oh, I got some extra marks on my... Oh, you're not done? Okay. Can I just... I'm just going to erase some marks that I have that I didn't need. I'll go real slow. Did you find both are dotted? Is that okay? Double check to see if I did that one right. I had y-intercept of 0, 1, and then the slope is 1 over 1, so from the dot I go up 1, right 1. Hey, how's the second problem set up to do? Cover method, absolutely. So we'll find where it crosses the x and the y-axis. I'll do this one in blue. Is that okay? Kind of like that? Does that look? Did I do that right? Yikes. So I hope this isn't the region we need to shade right here. That's kind of nasty, huh? Can I pick 0, 0? Can I pick 0, 0? That's kind of in between of them, right? It would be really nice if 0, 0 gave us a true, true. So we're looking for 0, 0 to see if that gives us a true, true. If it does give us true, true, I shade right in between these two lines. If it doesn't, we have to figure out some other place. Okay, so let's plug 0, 0 in. So we get 0 is less than 0 plus 1 is 0 less than 1. Yes. Cool, that gave me a true. Okay, so that means I shade all underneath the green if it was just the individual green line. Does that make sense if I say it that way? And then the second one, say if 0, 0 works. So 2 times 0, 4 times 0 is 0 less than 8. Hey, it gave me true, true. Where do I shade? In between them, right? Yeah. Let's go highlighter. We'll go to pinkish. Go right in here. There. This is my area that the answer falls into. There you go. Look at that. Oh, you can darken it a little bit more if you like. Huh. Wow. Okay. How do you feel? Yeah.
For your line of 2x minus 4y equals 8, why is there a negative 2 rather than a positive 2?
The blue one?
Yeah.
Because I had negative 4 times y is 8. So negative 4 times what number gives me positive 8? That would be a negative 2. 0, negative 2. So if I could use the cover method right there,
Yeah.
negative 4 times what number gives me positive 8? It has to be negative 2, so that would be negative 2.
Oh.
Did I answer that right? Jasper, help you?
That's fine.
Hey, can I move to the next slide?
And what was you doing? Downright,
For the green or the blue? The blue, so I covered both, so I found that across the x-axis, because 2x equals 8,
Yeah.
so 2 times 4, so 4 comma 0, and then the 0, negative 2 is where across the x and y. Right? So just looking at the blue, so if I cover right there, 2 times x equals 8, right? So 2 times 4, 1, 2, 3, 4, that's the x component. And then if I cover that, I'm going to solve for y. So negative 4 times negative 2, negative 1, negative 2. All right, if you can, go to that next page, see if you can figure out what might be taking place there. Both solid, both dotted, or one of each on this one? Both dotted. Everyone feel comfortable with that? Okay. So we'll just list dotted, dotted, dot, dot. So the first one we'll do in blue. Where's my y-intercept of my first one? 1. So I'm going to go right here. And from that point, what am I going to do? What am I going to do from that 1? Negative 3. That means I'm going to do what? Go down 3 and right 1. So from this dot, I'm going to go down 1, 2, 3, and right 1. And we said dotted, right? Cool. All right. Everyone will go? The next line's also dotted, right? All right. So let's figure this one out. Cover method might be a little nasty, but I think we can use it. Oh, shoot. So if I cover up the 2y, I'm going to get 6x equals 8. If I divide each side by 6, I'm going to get x equals 4 over 3. Is 4 over 3 1 and 1/3? Yeah, so in the x direction, I'm going to go to 1 and 1/3. It's like here. Right there. Oh, yeah. Okay. Now the other one works nice with the cover to 4, right? 1, 2, 3, 4. Oh my goodness, we got this little tiny skinny region. Ew. Okay. 0, 0 is on this side of both lines, agreed? Yikes. Okay, let's figure this out. So 0, 0 is my test point. I really hope it's true, true. I really do. Okay, so if I plug 0, 0 in the top, I get 0 is less than negative 3 times 0 is 0. 0 is less than 1. That's true. So that means I shade this side to the blue. If I plug 0, 0 here, I get 6 times 0, 2 times 0. So 0 is less than 8. That's also true. Oh, thank goodness. So we get this true, true region. It's over here. Look, abstract art. How do you feel? Number 4 is going to be done the same way. So let's move to number 5. Let's move to number 5. You all right?
Oh yeah.
All right, let's just go to number 5. How many equations appear to be on this line, or this grid? How many lines? 3. Agreed? Agreed? So, let's pick this one. It's a straight line. What kind of straight line would y equals 3 be? Vertical or horizontal? Horizontal, right? Okay, and it's dotted. This is dotted. Okay, so I'm going to go 1, 2, 3, and it's dotted right here. Ew, boy. Okay, everyone good with that?
Yeah.
So far I can shade below or above it. I don't know where yet. Second one, solid or dotted? Solid, okay. X equals 2, horizontal or vertical? Vertical. Because it's x, right? So 1, 2, solid. Okay. So far I can shade over here, up here, or over here. Oh no, I have this last one. Is this solid or dotted on this last one?
Dotted.
Dotted? Good. All right, my y-intercept is -4, so I'm going to go down 1, 2, 3, 4. And then I'm going to go up 2, right 1. So I'm going to go up 2, right 1. And you said it was what? Dotted? Oh my goodness. We have lots of regions that we could shade. We have down here, you can do here, 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 or maybe that.
0, 0.
Picking 0, 0, I'm with you. Okay, so let's try 0, 0. Let's see if that works. Okay, 0, if I plug 0, 0 in here, I get 0 is less than 3. True or false?
True.
True. So that means I shade down in the green, right? The other side of the green. Okay, if I plug 0, 0 in here, of course I'm only using the 1, I get 0 is greater than or equal to 2. False. So that means I would have to now shade, hang on, let's make this work. The first one, I shade everything underneath the green. The second one means I shade everything to the right of the blue. So right now, these are this region here and this little tiny region here, this little triangle. Those are the only 2 places that I can shade so far. So let's see if on this last one, if I plug 0, 0 into this last one, I get 0 is less than 2 times 0 minus 4. 0 is less than -4. Is that true or false? That's false. Okay, hang on. Look at the red line only. The red line only. That gave me false. So that means I don't shade on the top part. I shade on the bottom part. So here's my feasible region right here. I was hoping it'd be that triangle in there, but it wasn't. Okay? So, for tomorrow, I would like you guys and girls to do page 154, 155. Now, guys and girls, I might, as I said, I might have jury duty. If that's the case, I will have each of these problems written out on my video. I will have Chromebooks in here for the sub. So all your job will be tomorrow, if I'm not here, is do the notes. The video's there. You watch me. I'll be in the same outfit because I'll record tonight. I won't change for you guys. So you're like, dude, he wears the same thing too, dude. So, is that all right? Everyone good?
Yeah.